Hi, welcome to another video on my Raspberry Pi. Last time I checked the circuit with both motors, the electronic circuit with the op amp and pot meter to change speed. Let me show you, and you will notice that this motor stops running. So now I have to be careful that it doesn't lose contact, and with a little bit of help the second motor starts running, although rather slowly. And if you have watched the previous episode, you could have noticed that the voltage on this motor is somewhat 10 volts. On this motor, however, it doesn't exceed 1.5 volt. However, the intention is to use pulse width modulation. Now the range that I can use is 0 to 1024. Right now it is 500, and it would be a very good idea to explore a whole range of the PWM, pulse width modulation, before changing anything of the electronics. So to check everything, and before doing anything prematurely, I decide not to change electronics, but have a look what a value change may be in result. So first of all, let's remember what this does. It's now to the full. It runs fast. This runs a little bit faster than it used to. Crazy enough, this LED doesn't do anything. So I have no idea. And since the motor runs, it will work. Anyway, this is the current situation. So let's put everything to rest and do something with the software. And this can go very far to 0, so and now you see, which is a bit surprising to me, that the second motor starts running without any aid, and now it doesn't. So it's not totally consequent, but anyway, let's check it out. So, like I said, instead of changing the electronics, let's go to the PWM, pulse width modulation, and we are right here. On this line, I set the pin 1 of wiring PI to pulse width modulation output. And once again, a short recap: wiring PI 1 is the same as GPIO 18, which is the physical pin 12. And then writing a value to pin 1, which I've set here, and here you can see range 0 to 1024. So let's just do that. Do I need a microsleep? Can't hurt, I think. Anyway, let's just compile it, and according to instruction I have to use the GPIO class to incorporate the whole setup of the GPIO. Then of course this code, which is this one. Then as an output I want the file to be called GPIO motor, and then for the linker it has to include wiring PI. So let's do just that. No, I'm wrong, because I have changed this but I didn't save it yet. Ouch. So now I have saved it. Recompile. And then oh well, just sudo GPIO motor. And now I have put the circuit manually to 0. So I will first run it and see if there's anything else. You hear the motor running, I think, and it's already to the max. And that is not the intention, that I break contact. This is weird. I release the whole op amp. Yeah, now it keeps working. Alright, the circuit is running, and now I have to check with voltage, and maybe in another way as well, if this change from 500 to 1025 actually has a result. So let's see if that is so. So now I have changed the value to 1024, and let's check on the multimeter once again what the value is. Probe on the minus, probe on here, and it is once again just half a volt on full scale. So with the motors running maximum and the voltage here still at half volt, what you can also see is that this LED, and I hope you can see it, that this LED is actually blinking very fast. Now there's another solution, because information tells me that for pulse width modulation I better should use frequency. So I take away this multimeter and put this multimeter on, set to 20 kilohertz. So if I measure now, it says it is about 0.59 to, well, average maybe 57, 60.6 kilohertz. So with this, I wonder if I change it back in code, what the frequency will be. And I will do this just outside or off camera bit, and I change it to 250. Is that wise? 256, but just 256. I exit the program, and you heard a slight change in, no, I recompile. Start the program again. So now everything running on full, but with a different pulse width modulation frequency. I check again. .86, 13. So that's quite a difference. This is quite a difference. But it goes down and down. It varies immensely. So what will happen if I change it once again to 512, which is double the value it has now? Let's check that. I quit the program. Quick change to 512. Recompile. Start the program again. You can hear some change in speed, but I ignore that for now. And we read about 485. It's a little bit lower. So this is interesting. The higher the value, the lower the frequency. Now if I hold the probes like this and change this, and I try to put the second motor running. A little higher. And the second motor doesn't want to run at the moment, but you see that the frequency has changed a bit. So let's play with this a little bit more. Okay, the second motor turned out to be disconnected, so I had to reconnect it. And I changed the pulse width modulation to 768, and let's turn it on again. And second motor is running. So let's check for the frequency now. Here and here. And now it is quite low. So the higher the pulse width modulation is set, the lower the frequency for this motor is. Does that go for the other motor? I think so. So let's measure right here, and yes, of course. So this is quite interesting. What happens if I put the value right up to 1000? I made a slight mistake. Let me measure once again. I did not start the program, to be honest. Now I have. So this value is now around 2 kilohertz. And that is with pulse width modulation of 768. So now I'm going to put it to full 1024. Let's see what happens then. And start the program again. Probing again. And it stays around, no, it's yeah, it stays around 2 kilohertz. So that is a little bit surprising to me. Anyway, this is a very nice result of measuring, and the voltage has not changed, of course, but that is still something which is curious, why that motor runs on 1.5 volt. But more interesting, I think, is the pulse width modulation. And with that, I think I can check out more about it. So let's figure out more. Yes. To conclude this episode, I want to focus on this LED. because I noticed that it was going on and off in a rather high frequency. So right now, dimming the light, I don't see it as much. So let me change the frequency again, back to 500, 512. Oops. And then of course I have to recompile. Start the program, and I wonder, wait, that is another problem I noticed just now. The transistor is completely off, which I have to redo, and I have to set it properly, of course. The whole circuit is off. I noticed just now. That is not a very good thing. This one should be here. This one right here. So. And now I once again see the LED going on off quite fast. Exiting the program has no influence, which is a bit curious. So let's check the frequency once again. Back at 1024. Another recompile. And then see what happens with the frequency in here. So let's check, probing and probing, and yes, it is lower than 2. So I have this part of the circuit set up wrong. So yes, the higher the pulse width modulation, the lower this frequency is. And if this is mattering, I honestly can't tell right now, but I will change the value to 256 to see if that matters. Now we recompile. And since the program has stopped and it is still flickering, I don't think it matters. Now it is still going, and this will be a higher frequency. Yes, a rather high frequency. with 256 pulse width modulation. So that is very interesting and a nice conclusion, and open for more ideas. So for now, thank you for watching, and to be continued.